Supplemental math videos from Circle Christian School. Angle relationships in circles. Again, now we're to the point in geometry where you have to know about the property because it'll help you set up the math. Things that you can do is make little cards of each one of the little properties so that you have them to go back to. A good page in one of your spiral notebooks so that you have a page to go back to. At the end of each chapter, there is a list of things that you have to know about that chapter and the geometry and the properties. You can almost copy those and have them to go and look at. But today's focus is central angles and arcs. Discover how angle measurements from chords, secants, and tangents have these special relationships. Or try again. All right. Here's the deal. Remembering that when we have inscribed angles, that's the guys that are made out of chords and have a common vertex, that their measurement is always half of the archy that they intercept from the central angle, the guy off the center. So if the archy is 98 degrees and the central angle is 98 degrees, then the inscribed angle is going to be half as much, which would be 49 degrees. And because RTU intercepts that one too, it's 49 degrees. Yay, yay, yay. And then we take a look at the inscribed angle of SUT is 31 degrees, so the archy is twice as much, so it's going to be 62 degrees, which means inscribed angle SRT, follow me with your fingers, is going to be half as much, so it's 31 degrees, and that's how it's done. Now, a quadrilateral can be inscribed if and only if the opposite angles are supplementary. So we have to take a look at the opposite guys, like 4B plus 2B, and they have to be supplementary, so they have to equal 180 degrees, which is going to give me 6B equals 180 degrees, and so B is going to equal 30 degrees. That means angle D here, once you put the 30 in, is 120 degrees. And angle B here, 2 times 30 is 60, and yes, if you add those together, they do equal 180. Likewise, when we take a look at angle C and angle A, they also have to equal 180 degrees, so we have 2A plus 2A equals 180 degrees. That's how the math is. You got to make everything equal 180 degrees here. 4A equals 180 degrees. That means A is going to equal, let me see, 45 degrees. And so this one's going to be 90 degrees, and this is going to be 90 degrees. And when we add up all the angles inside of the quadrilateral, they would equal 360 degrees. And look, it's beautiful. Now, my suggestion for all these different things that happen to angles inside of a circle is to do one of a couple of things. Number one, you can make little cards with an example so that you can always go match it up. If you know the property, you can do the math. At the end of every chapter, the properties are all down there. You can make little cards, make a little copy, put it in your little spiral notebook so you have something to match. Make these drawings so that you can match them up to what's happening to the problem that you're faced with, and then you know what to do with the angles. So for more angle fun, we need to find archy X, angle Y, and archy Z. All right, so angle 2 here is 125 degrees. which means it was half as much of archy x. So archy x must equal twice as much, and it's 250 degrees. So if it's 250 degrees and all the degrees in a circle is 360, archy 110 degrees, which means angle y is half as much, which would be 55 degrees. Now here's our double checks. 125, 55, does it equal 180? Yes. 250, 110, does it equal 360? Yes. Everything's beautiful and great with the world. Same thing when we have two chords that intersect inside of a circle here, that to find angle 1, we have to take an archy DC and add it to archy AB and divide it by 2. Likewise with angle 2, archy BC plus divided by 2 is going to give us angle 2. So I have 130 and 156. Know the property, you can do the math. 6, 8, 2. So now we need half of that, which is going to give me 1, 4, 3. So angle 2 equals 143 degrees. Now, knowing that angle 1 and angle 2 here is supplementary, that means angle 1 has to equal 37 degrees, because that would give me 180. All right, archy DC is 40, which we will add to the 286. Six, 2, 1, 3, and we'll subtract that from 360, which would give us 34. So this would be 34 degrees. And we can do the double check. If we take 34 and add it to 40, we get 74. And half of 74 is, surprise, surprise, 37 degrees. And all is great in our circle world again. Okay, last thing of angles that happen with circles. This is where we have two secants, and remember those are lines that go through the circle from the outside to the outside, and we have an angle that goes together with both of those secants. All right, this is very simple. Big archy take away small archy divided by 2 gives us the angle. So for the first one here, I'm going to go 178 minus the 76 is going to give me 102. Divided by 2 is going to give me 51. So angle 1 here equals 51 degrees. Now sometimes what we have are tangent lines. Those are lines that hit the outside of the angle at a tangent point and meet at a common vertex. And that again is going to be big archy minus small archy. But a lot of times they like to sneak this in on you here and only give you one archy. Well, it's not that you don't know the other archy. You have to remember that if you go completely around the circle here, it's 360 degrees. So to find the big archy, you're going to have to take the 113 away from the 360, which is going to give you 147. So the big archy here is 147. You have to kind of like do 2 steps with this one here. So now I'm going to go 147. Take away the small archy of 130 degrees, which is going to give me a 4 and a 3, 34 degrees. Half of 34 degrees is nope, that's not right. That's 247. Can't add today, guys. 247. I like that so much better. Okay, so that's going to be 134. So half of the 2 divided by the 2 again is going to be half of 13 is a 6. 1 left over here, 67. Angle 2 is 67 degrees. And that's how the big boys do it.